Morning. We are back live. This is a little unfortunate. This experiment goes like this. We're gonna have to figure this out a little bit. Let me get set up here. And we're gonna look at all the experiment results. Oops. I'm gonna kill this because this is not working and it's eating all the memory. Let's see what we have here. Yeah, so this crashed. Not too happy about that. Let's just do this. It was definitely promising stuff. All right. This one looks even better than that, but it doesn't converge the same, it looks like. And this one has been still training, and look, if you see it was here before. So now it's up at 4. It's like this pretty smooth log curve. Okay, so this is just a precision thing. That's unfortunate. Man, I wasn't sure if I should have done 0.0. I probably just should have done that. Wait, let's... There. That'll run. I think this is zeroed, right? Yeah, this is zeroed. You know, it is interesting that they are selling stuff. And they're buying stuff as well. There is actually market use going on. That's pretty cool. So, I mean, this thing is working. I would really like to understand, though, what is going on with this discrepancy right here, right? How is it working compared with previous? Well, it's better than Atom. Muon's doing great. We're just looking at PSGD and if we can get this to do better than Muon. Here, let me show you this. So this is Muon right here. That's a clean learning curve, right? That's a really clean learning curve. It's just a log. Just straight up a log function. But then I'm trying PSGD, and you can see if I go zoom in here, right? It looks really promising, and then it intersects. And it's done that with basically every one of the experiments so far. An episode return as well is consistent. They just say sweep more hyperparams. And like, they're probably right. We do need to just sweep more hyperparams. The runs are kind of expensive, you know, they take a while to go. I tried to do these last night, and the run crashed partway through. I mean, you can see, like, there's a lot of variance in here. Big issue. Let me just give him this graph. Maybe one of these guys will figure this piece out. All right. That's going to take forever to run, so we're going to have to figure out some stuff to do in the meanwhile. I think I'm just going to go through some of my thoughts on what I've been doing with this optimization stuff lately, and maybe some of the remaining problems. So I was looking at a whole bunch of different techniques for just general purpose RL improvements, right? Like, how do we modernize the RL stack? And I don't mean like add a bunch of fancy tools. I mean like, why don't we go check out the optimizers that LLM people have been using for the past while, right? Why don't we go check out like the learning rate schedules? For instance, nobody uses linear learning rate decay. They use cosine annealing. All right, so I grabbed a few things like this. And I think the optimizer was the biggest one, but the other ones definitely helped as well. And basically overnight, the breakout speed run time was cut in half. And every single environment is essentially solvable now with the same set of parameters. Not optimal, mind you, but pretty much way more hyperparam stability than before. Definitely not optimal. So with bigger problems, you're still going to want stuff tuned. So then I was looking at, okay, well, what can we do from here? Because there's still a few things that are a little bit janky. First of all, I wanted to say, okay, can we make the learning rate pretty stable? Because that parameter usually varies with model size. Had a long conversation with the optimization folks and looked at the math. And yes, it turns out that actually any of these new optimization methods are going to give you invariant learning rate with respect to model size. So that's MuP, what that used to do. This is kind of just built in now, which is really nice. Now, there are a few additional sources of need to change hyperparameters per env, right? One is that some envs just have way more gradient noise than other envs. That's something to look at. And that requires you to use, larger mini batch size or lower learning rate in order to solve the same task. And then the other one is effective horizon, which, possibly these could be related as well. But gamma and lambda, the GAE parameters. Now, it's interesting that, stuff does kind of work with the same set of params on a lot of different envs. But there was at least one where I had to change it to make that work. And ideally, we wouldn't have gamma or lambda at all. So that's what I was doing with P30. So I think what we're going to do today then, I have a couple of environments to play with that I need to start getting some more results on with Puffer. And then I just want to play around with P30 with the new optimizer stuff to see if it makes it work better now. Because it should be a lot easier to experiment now that the hyperparameters should be a fair bit more robust. We should be able to make some progress. And then in the meantime, these experiments will run in the background. So I guess then today we'll look at gradient noise. We'll look at P30, run a few experiments on that. We'll look at that new environment and we'll see where we get from there. That sounds like a plan. Let me move this off to where I can keep tabs on it. Okay. Let's make sure breakout still works. And I believe this learning rate is too high for it as well, isn't it? Let's see. We'll Neptune a few of these. Where's the run? Oh. Okay. Let me go check what the default learning rate was. I think it was 0.01 or something, 0.001. So this learning rate should be way too high by those standards. Yeah. It doesn't completely fail though, which is interesting, even with like a ridiculously high learning rate for this algorithm. Try it with their default. Okay, something's wrong then with these defaults because this was working really, really well before. What about precondition? So everybody tells me to drop the precondition learning rate. I'm pretty sure though I had it in the sweep. Yes, it's in the sweep. The hell is this plasticity annoyance that everybody keeps talking about? Do I have to actually go look at this stuff? Oh, hey, Captain. Dev branch attempting to train Impulse Wars. What should I set CUDA? I never set that variable. Should not have to mess with that. Getting that one trying to load new CUDA files? Yes, you are. I tell you what you're missing. So, are you on Puffer Tank? Is this on the box? Okay, so I can show you. You don't have the right version of CUDA. Let me show you. It's not a pip package. So even if you're not going to use this, if you just look at our files once in a while in here, you need the CUDA developer. You need CUDA development version. Without dev, you can't build. You can't build like the new extensions and stuff. Though I don't actually know why that would be a problem in your case if you don't have like our advantage estimation stuff. But this is what we have at the moment. Yeah, you can probably get like CUDA dev or whatever. I'd have to see the exact error. Thought 4H PSGD cron worked. Yeah, so something weird happened here because the learning rate there. Oh, it's because Breakout has its own learning rate. I'm dumb. There. So this does work. We'll double check this. Somebody's linking me plasticity stuff. L2 regularization does just as well. Maybe we do need L2. Maybe we do need L2. Nothing private with these DMs. It'd be more interesting than me just like sitting here typing stuff on the side. Something like pre-training for any epochs in the first 50 class from fine-tuning on 51. It learned, but it never reaches the same accuracy or loss. Fortunately, this doesn't seem to work either here. This trains, but it doesn't train well. I just do moo on. Oh, it's trained on Optim. Without activations. It looks like he's done some stuff on this. I'm trying to think what we do with that. I'm just hoping this isn't some dumb nerd snipe like exploration is, but it seems like this is potentially legitimate. At least it's quantifiable. 23385. I just want to see if the hypers are like way different. Okay, so bigger gradient norm and entropy. Oh, this thing is screwing with the value coefficient completely, isn't it? This thing is like totally screwing with the value coefficient. I mean, that shouldn't work though. That shouldn't work. If that does work, then that tells us there's a big problem. My CUDA just crashed. Zero. Oh, that's gonna just screw up the value function, I guess. It's funny it can't backprop 0. This is not even training a value function. So what does that even do? I mean, this should just basically be reinforced, right? Yeah, this has got to just be reinforced. It's interesting though because I think GAE without a value function doesn't give you reinforce. I'm gonna have to look at that. The fact that that does better is concerning. Okay, I'm gonna be back in a little bit here. I'm gonna think about this. I'll be back, I don't know, 5-10 minutes, whatever. I'll do a couple quick things. And we will definitely look more at this algorithm and see what we can do about it. I'll be back. Okay. Let's first see if our sweep is still working. Looks like it is. Hmm. Yeah, we got some runs here. Kind of crazy that reinforce out of the box. Basically, reinforce will do 400 score. Well, I mean, I know for sure that you can get way higher score with this algorithm. Question is why it should need to be tuned separately. Let's take a look. Yeah, so it was this run right here with this pretty low value function coefficient. And I wonder if there's something to that. You know, maybe there is actually something to that. It has a whole bunch of different heads on it. I just want to see if this learns better than before. There might be something about like slow learning value. I mean, and other than that, like, slight entropy difference. But we have, what do we have entropy? 0.1. Yeah, see, these are like all pretty dang reasonable. These are all like reasonable defaults. What did we get? This is lambda gamma 996 into 83. Oh, you know, the other thing we could try. Yeah, hang on. I know the other thing we can try here. Yeah, so there's nothing magic about like small but non-zero value function coefficient. It's just weird. So the other thing we try, let's try this with muon, or with what I mean, with just PPO. So this should now just turn into like discounting. Interesting that this actually looks like it does way worse. It really is then the value function. Yeah. What about can I find like the best results I had on this? Because I don't think that one was particularly good. Nine. I guess this one maybe. This was probably the best. 2, 4. $93. This is pretty well on par with the PPO solve time, I believe, before Muon. So we should maybe be able to get something out of this. 24 M's. Okay, so there, you see there is a reasonable value function coefficient on this, a 0.6. So I think what we'll do is we'll try that next. It could just be something with the magnitude there. Arm of 1. That shouldn't matter. These two explicitly don't matter. Did I? Yeah, I forgot this one. ESP30. That's interesting. So this is our baseline, right? It's better than before, but still not there. Low clipping, so gradient norm shouldn't matter. Learning rate of 0.05. Do you think these could have different learning rate requirements? The thing is, it's just default. Now it's literally just the default. Also noticing this was 2 epochs. Should be able to get something working better than this at least. If this algorithm's any good. Are we learning the value function here? Let me see. I mean, it's... eh. This is a stupid green one. Get rid of this. I don't want to just sit here manually tuning hyperparams all day. That's a huge waste of time. But I do want to develop some understanding of this problem and how we can fix this thing. I mean, this could literally just be as simple as retuning is the thing as well. I think the smartest thing to do would just be to like keep queuing up more experiments on this stuff because there's just a lot of stuff to test. I think the smartest thing is going to be to just keep queuing up experiments and then do the stuff I know I can make progress on in the meanwhile. I'll let this one run though since we already have this, just to see if there's any difference. Got impulse warning on dev perf is same, a tiny bit slower. It's slower because the optimizer Muon has 10% overhead, and cron has about 20%. They work way better though. I'd start with Muon for now until I figure out if there's something weird with cron. Okay, well I can definitely convince myself from this that the value function magnitude is definitely important here. Let's put 0.3, last experiment. Well, I just think about what else to do. I think we're gonna probably want to do gradient noise. If we can do gradient noise next, that would be cool. If you put import, reduce overhead speeds up. Oh, perfect. Yeah, that's what I wanted to do. That's what I was looking for. That's been annoying the hell out of me. Mm-hmm. Much appreciated. Oh, you know, because I refactored that thing recently, I have to fix that every time. You have to fix that every time you use Puffer because you haven't fully updated yet. I don't even think that's getting imported is the thing. Like, if you look, we don't use these at the moment. Right? There used to be this additional layer where you had to wrap everything in this, and I got rid of that. So I made the stack thinner. I've been meaning to refactor those for compatibility with CleanRL. The idea is that we make the main code path simpler so that you don't have to wrap anything in order to use our demo code, and then maybe you have to slightly wrap something if you want to use it with CleanRL. Don't use recurrent wrapper, you just use the LSTM wrapper. You just directly use the LSTM wrapper now. It's easier. Alright, so what we're going to do for this then. Interesting default. Yeah, that is what we found, Captain. So this was the major breakthrough, right? I swept this with breakout. Those params are roughly tuned for breakout. And they work just about as well as tuned Atom on everything else. Sometimes better, sometimes a little worse. We're not done yet, though. You should definitely do a comparison against, your original. Oh yeah, Captain, can I see your sweep config real quick? I want to check something. I guess it's just in here somewhere. Custom. One thing I would try just immediately, and this is not a good idea, this is a hack until I implement this correctly, but just up your mini batch size. What do you have it at right now? Where's mini batch? Oh, you already have this massive, never mind. Yeah, then this is fine. Yeah, this should already be good. Yeah, but you can try to keep this big mini batch size. I noticed with Neural MMO, it doesn't seem to work on small mini batches. What should and shouldn't I sweep over? You can kind of sweep whatever I have in the defaults if you want to. It's just a lot of stuff to sweep. You still need to do gamma lambda. Entropy you still need. The learning rate's the biggest one, probably, at this point. Mini batch size is important. Big batch size has been helpful. We have 500K default mini batch has been useful for pretty much everything. You might just even want to just keep that. We're also able to use more environments now. It seems training with more M's is stable. Not like that. Would you bother sweeping update epochs? No, you don't really have to bother. I think we did increase the BPT horizon default. How do you compute the gradient over multiple elements? They do a fucking loop. Oh, what's this? Nah, this doesn't work either, does it? Well, I also use the trick you do in Neural MMO 3. How do you get it to work in a sweep since the batch size changes? There doesn't seem to be a way to pass custom args to policies. There is. If you just do policies here. You see? If you just put a policy block in the ini, and you can put sweep as well, it just passes it. Like, there's not even an API for this or anything. It's literally you just put stuff into the ini file and you just pass it in and you're good. I think what we're going to do for the gradient stuff here is... can't I just... I can actually do this. I'm dumb. Hold on. Yeah, I've been really dumb. Isn't it just divided? I think it's linear. It might be a square root. Or it might be, I don't see to easily pass batch size to the policy based on what the sweep algorithm suggested. Just in your demo code, right? In your demo code, if you want to do that, oops. Just pass it here, right? Or does this only get train args? No, this has args. Args is, hang on, make policy. Yeah, so you can just pass args of train. You can literally just do this, right? Args, train of, what did you say, batch size? You can just do this. It'll be good. Protein rand samples is 50. It's not 50 experiments though. If you look at the way we do it, that's 5 experiments. You get the entire trajectory history at the moment. So we take the whole loss curve or the whole training curve. We subsample, so we get 10 samples from it. And then you give 10 samples per experiment to protein. Wanted to make it the number of params. Yes, assuming that you actually have my subsampling code, because you do have a custom demo file, right? Because it was originally demo.py, because it was originally just demo, and changing the name of the main file too often pisses people off. So we might change it for next release. I mean, what should I call it? Inflate? Is it this slow? The heck? Really? You wouldn't expect it to be that slow. Oh, train mini batch, you dummy. Yeah, dummy. There we go. There we go. All right, let's put this on Neptune. And then get a run of this. And then we'll try neural MMO. Main.py? I don't know. Sounds lame. Okay, so here's a gradient variance. Looks like it has way lower variance, right? Long does. What other end should I use for this? Snake. And puffer snake. And then we try neural MMO, and we see the question is going to be if gradient variance lines up with like rough perception of difficulty. It increases. That solves really, really fast now, doesn't it? I'll let it go for a little longer because I know the training dynamics are kind of interesting for this. I wonder if they had reports for some of their M's. I think that they did. Okay, that's good enough for this one. And then what about neural MMO 3? Well, there was a huge amount of gradient noise at the start right there for a second. Yeah, it was way up there. Starting to optimize a little bit. So we'll see if that translates to gradient noise going back up. I guess its gradient noise is low because it's just not finding anything for a while. I have a few more of these in here as well. How did they compute this actually, this variance? Well, the other thing here with this prediction is that you should be able to train with smaller batch size, right? And lower learning rate. Just getting around to fixing projectiles. Projectile lab is 120 floats. So linear 128 torch max. And then, yeah, concatenate to encoder or whatever, yeah. That would be the suggestion. This doesn't seem like a super clear metric to me, this gradient noise scale. I wonder if this is just a proxy for reward sparsity, honestly. Or reward variance. So I guess with like muon in particular, we should be able to do some sort of experiment to demonstrate batch size, mini batch size invariance, you would hope. That's a good thing to do. Yeah, the fact that this variance is so low is odd to me. I mean, the vast majority of these are getting no reward though, so this is probably just a measure of sparsity and more than anything. Yeah. That's interesting. So I don't know about this as this gradient variance is a useful measure. I mean, it's nice to log, but I don't know if it just tells you much on its own. I think it is increasing, but the scale is very low. Oh wait, unless, did I do this wrong? On times mini batch size. Yeah, this is correct. It should be times mini batch size. So yeah, the gradient scale doesn't, I mean, it is increasing. I'll let this run a little longer just because it's going to increase pretty quickly maybe here. But like the absolute scale doesn't seem to have anything to do with the task difficulty and definitely is not predictive of the batch size that you would need. It's a little odd that they actually found that in Dota that it works because I don't see it here. I suppose it could be that this just increases very high over the course of training if you train a good model. So at least I can confirm that result, that for some environments or many environments, it looks like the gradient noise does increase over the course of training. The actual magnitude's lower than the magnitude of breakout noise by a lot. I wonder if there is any theoretical basis then for like if you made the gradient accumulation proportional to the variance. The problem is like I think gradient variance 0 could either mean that you have a perfect signal, well, I think you also have no gradient variance if you're stuck and aren't getting any reward, right? Yeah, then you have no signal. So I think that this thing is kind of brittle. Okay. Let's try a couple just quick experiments on breakout. So I want to test some stuff. I want to see if we can actually get the behavior that we predict in practice. so we're gonna do divide by 8. I'm going to 1024. I'm going to see if this curve matches roughly. Oops. Definitely slower wall clock, but that's expected. And there is still potentially a little more jitter, right, in the smaller updates. Though this should be matched. For the most part, this should match. And then we're gonna check a few things around the learning rate here. So I think there is something with Dota. So this is hardware scaling. So when they say really big batch size is essential, Oh wait, do they have something on learning rate here? Do they just use the same learning rate? Okay, so we get to 790, which is not quite as good. A little bit of a gap there. Now what we do is go back to the original learn rate, run this again. Keep looking at the paper. Not this one. Where'd the paper go? Think I'm doing something wrong. There are 30 projections with 4 floats. There are 30 projectiles with 4 floats per projectile ops. In that case, 128 seems really high for an input of 4. Well, yeah, and that's where it can be potentially slower. The issue that you're going to run into, though, is it's not just 128 for an input of 4. 128 is the total embedding dimension that you're going to compress all those projectiles into, right? So it's actually 120 going into 128. It could be that it's very slow and then we have to fiddle with something else. So, I mean, this does not behave perfectly predictably. This staleness thing is crazy. The staleness thing is really crazy. So I'm pretty sure this is wrong. This is what I used as my, I used this for a very, very long time, but recently I took another look at GAE, and I think it's really gamma times lambda. Maybe it is gamma. It's hard to say from the formula. I don't know about this, though. Okay, so we have our new... Ah. So this actually matches. This matches the original pretty well, right? What if we do 16K? Does it still work? Okay, but this is half the number of gradient updates as well, right? So it would be like here-ish, was it? Halfway to here is 40, so it would be right there. These match very closely. .96. Need to try on a puffer box. My desktop doing this drops 100K SPS. Well, yeah, it's a lot of encoders, right? You can try 64, for instance. I mean, the alternative, right? The alternative would be you do some pre-processing on them. You know, you'd have to like order them or sort them or something. Because right now it doesn't know what, like, it's got to learn what projectiles where as well. Oh, look at that. So we'll see whether in wall clock this is better, but look at that in steps. Okay, another version of this, right? Another version of this is just that the learning rate doesn't vary linearly, right? Like there should exist some learning rate for which smaller batch does better than bigger batch. But now look at this. It's not bad, but like this 4096 one here. Speed question, is fast compile that much different than normal when testing M speed? Wait, what is fast compile? Is fast compile that much different? I have the 6x, yes, that's completely normal, Spencer. So basically, like, you know how in Python, if you try to access an element of an array that's out of bounds, you get an error? And like, there are a whole bunch of safeguards like that. So those compile flags inject all that stuff into C. So you essentially have like a modern site, like safe language, right? But it's way slower. And there's not really any effort to make those checks fast either, because it's meant for debug mode anyways. kind of vary a little, right? These like vary a bit. I don't see like a clear trend though. So I mean, this is like better. We'll see how this goes longer term. But still doesn't seem like it doesn't seem like you get anything out of the smaller mini batches, right? That could be related to other properties of the optimizer though. Right, maybe it holds for SGD only or whatever. It didn't do better than before though. It did about on par with the one where we just kept the learning rate the same. Hmm. Get out of here, bot. Full block list of Twitch bots at this point. Thought for a while Env was way slower because I was only checking speed on debug. Yeah, that'll happen. I added the compile flags, like I added those modes for a reason, right? Not just to show off. I think I got to implement gradient accumulation next, is what I've got to do, because yeah, right here, this is kind of showing me that mini batch does not behave exactly the way that you would expect. You know? You always get better results on a per step basis. So there is a critical size, it seems. And what they were calling a critical batch size is really a critical mini batch size. And then actually batch size to mini batch size gives you staleness. Ooh. Okay. I see how this is. Time is it? 11. I think what I'm going to do is I'm going to go think about this for a bit. I'm going to get some exercise in, get some food, and then we're going to come back. We're going to implement gradient accumulation, and we're going to try that out. So that'll be a new feature. And let me just make sure that these other sweeps are still running correctly. These have crashed a bunch of times, and it's a total pain. They seem like they're good this time, though. Let's see, do we have anything cool? Oh yeah, we've got some cool stuff here. Look at that. Boom. First run that beats, first few runs actually that beat the previous winner. This is still nice and steep as well up here. So we'll keep going on this for a little bit. What did this run do differently? It didn't drop like M's or something. M's, this is good. Yep, fixed gamma lambda. Max mini batch size, you can see right here. Change preconditioned learning rate. Drop this by a factor of 2. Learning rate's pretty near the default. It's upped it by a little bit. A few other things, but this is like reasonable. I'm happy with that. Okay, cool. Yeah, I'm gonna go get my exercise and stuff, and then we'll see where we go from there. So for the couple folks watching, Puffer.ai for all my stuff here. You want to follow all this reinforcement learning dev, go start the repo on GitHub. Really helps us out. Other than that, you can join the Discord to get involved with dev, and follow me on X for more content.